Thank you all for coming. I do appreciate it. I know it's been a long couple of days. I do appreciate everyone who's come here on the second day to hear me talk. I'm going to be talking about InfluxDB and time series data in general on the IoT Edge. So just a couple of things first. I am a community manager and developer advocate right now for InfluxData. But before I was here at InfluxData, I was a developer advocate at the Linux Foundation, working on the LF Edge family of IoT Edge projects. Before that, I was at Canonical working on the Ubuntu project and its various technologies, packaging, and distribution options. In this talk, I'm not necessarily trying to give you advice on what tech stacks you should use, but I'm sharing what I know, what I've seen other people using InfluxDB for on the edge so that you can get an idea of what the ecosystem is like and what your options are available there. If you are interested in InfluxDB and IoT, we have a dedicated Slack channel here. If you go to influxdata.com/Slack, you'll be invited to that, and then you can just join that Influx IoT channel and talk to people who are working on similar projects to you. You can find this slide deck on my website, mhall119.com, or on Twitter. If my TweetDeck scheduling worked properly, that should have been tweeted out just a few minutes ago. There will be links at the end of my slides to all of the different projects that I mentioned. So if you want to go learn more about one of those things, check the slide deck and you'll be able to get the links there. And last of all, I'm hoping that at the end of this, we'll have some time for questions and answers, and also for anybody here to share what their IoT tech stack looks like. Again, I'm just sharing what I know and what I've seen, and so I would like to hear from other people and other perspectives about what's going on there. So before we get into it, I want to talk about a couple of the technologies I'm going to be mentioning quite a bit through these slides. And the first one is InfluxDB. If you're not familiar with InfluxDB, it got started in 2013. It was originally, the company was founded as Airplane, ERR plane, and it was meant to monitor error metrics coming from services. And our founder, Paul Dix, realized that he needed a high-performance time series database to gather those metrics and display those metrics. And so he started building InfluxDB, and it soon became apparent that that was the more interesting and more important part of everything that he was building. So the company shifted, it became InfluxData, and InfluxDB became our primary focus. We are still an open source database, and I feel like this is important because a lot of databases recently have been relicensing to try and head off competition from the likes of Amazon and other cloud providers. So they've been switching to like shared source available licenses and other non-OSI licenses to try and stop that competition. We took a different approach. We stuck with an open source license, and we decided that we were going to outcompete Amazon. So we built our own cloud service for InfluxDB, and we plan on building it faster, cheaper, and more reliably than Amazon can, so that they cannot steal that out from under us like they have done for some others. We are a time series data platform. We started out strictly as a database, but over time we've grown. We've added features and tools to expand beyond the database layer to make more things available for app developers who want to build something on top of it instead of just a database. One of the first things that we added was a dashboarding component built directly into InfluxDB. You can still use Grafana. That's still one of the most popular connectors to InfluxDB, but if you need just a basic dashboard to monitor the metrics that you have coming in, we have that built into InfluxDB now. We also took the graphing component that we built to show these graphs, and we split that out into its own JavaScript library called Giraffe. So if you want to build an application but still want to display charts like this within your own application, you can just use that library, and it connects directly back to InfluxDB and makes that a lot simpler for you. We also created a new domain-specific language for dealing with time series data. Previously, we had two different languages. We had a SQL-like language for querying data, and we had something called TickScript that you could use to do data manipulation. And that was confusing, and that was two different things that developers had to learn. So instead, we combined the best of both of those into what we call the Flux language, and you can use that to build really, really complex queries, more complex than you could with our old SQL-like language. But you can also use the same language to do data transformations and downsampling and alerting, and things like that. So it's all one language now that powers all these different features within InfluxDB. And like I said, we do have alerting now. So we've got a component in the UI where you can set different thresholds to get a notification on your phone or in your Slack or on PagerDuty, wherever, when some measurement goes out of range or stops reporting. Underneath that, it's just generating some Flux code for you that's going to live inside the database and periodically check your data and fire off those notifications when necessary. Another thing that we have are tasks, which are, again, Flux scripts within the database, but you can schedule these to be run inside the database to do things like downsampling, to do analytics, to do machine learning. And again, those all run inside the database itself. You don't have to pull data out to do that processing anymore. You don't have to have a separate node or instance to run those calculations. You can just save the script right in the database, and it takes care of all that for you. We have language bindings for about a dozen different languages, so whatever you're using for your own project, you'll still be able to get a native library that you can use to interact directly with InfluxDB. And in the IoT space, things like the Arduino lets you really quickly prototype new setups. We've got pandas and pandas data frames built natively into our Python client, so if you're doing any kind of data science or machine learning, that makes that really easy to get to. Node.js is what we use for our front end, so we use the same client library for that. And we use our Go library for our InfluxDB CLI. So we consume all of these. We make sure that they're really top-notch and easy to use. We also created a VS Code extension. This is relatively new, and it uses, again, that Node.js library and a language server project on top of that. So in VS Code, you can install this extension. And that not only gets you syntax highlighting for your Flux scripts and autocomplete for your Flux scripts, but you can actually, let's see if my pointer works here. Probably can't see that. But you can see, connect to your InfluxDB instance and see what data you have in there and what your data structure looks like. You can pull in your scripts from your tasks and your alerts to edit them within VS Code. And you can actually execute these queries from VS Code against that remote database, and it'll pull the data back in and display it in a table in a separate tab inside VS Code. So you never have to leave your editor. You can write your code, test your code, get your data, put it into your own application without ever leaving the editor. And all of this is powered by a really robust set of APIs that we've built up around the platform. And this is beyond just querying data from the platform or writing data to it, but being able to manage almost every aspect of it, from setting up users to defining and kicking off tasks. You could even create the entire dashboard using the APIs and just programmatically build those. We've got somebody who's got like a self-serve portal where people can do something in their interface, and it automatically builds a dashboard custom for them. And all of this kind of builds together around that core open source InfluxDB database that we started with to build a really robust developer platform that's useful for a variety of use cases, from big enterprise monitoring, network architecture monitoring, IoT monitoring, which is going to be the focus of this talk. But because we have all this built, working together, integrated together, we can do something that we call InfluxDB Templates, and that's where you can take everything, all the metadata that you've built up within an InfluxDB instance, and you can export it as a YAML file. And once you have it in there, you can put it in source control, you can track changes to it, you can iteratively develop on it, either directly in the YAML, or you can do it in the InfluxDB interface and export that again. And then you can take that template and you can apply it to another instance of DB to get an identical setup running there. And you can iterate on the template, and you can save it in source control, and you can deploy that new version of it out to the exact same instance you had before, and it's just going to upgrade in place the setup that you have there. So that really enables the entire GitOps workflow, CI/CD workflow that you already have as part of your database management side of things too, so in addition to your code. Another big component that we have, especially in the IoT space, is called Telegraf. Telegraf was started very shortly after InfluxDB got started, when we realized that we needed a real easy way to get data from, at the time, mostly services that are being monitored into InfluxDB. It is also open source under the same open source license as InfluxDB itself, and it's run as an open program too. So Even though we started it and have been the primary maintainers over it for most of its lifetime, over the past year, we opened up the maintainership and commit rights and everything to members of our community who have been active and engaged in it for a while. So now the people who maintain the Telegraf project is a mix of InfluxDB engineers and community engineers all working together. They have like weekly meetings to go through pull requests and new feature planning and things like that. So it's really developed in the open. It is source and destination agnostic, even though it was designed to get data into InfluxDB. It's not limited to that. And it's not limited to specific, like pulling data from web services either. We've got, I think, 300 plugins now, and only about 10 of them have been written by InfluxDB. The rest are coming from community contributions to enable their own needs. And I mentioned plugins because it is entirely plugin driven. The agent itself doesn't know how to do much other than schedule and run plugins and make sure that they're running happily. Everything else is done in the plugin code itself. We've got like 200 different input plugins for different protocols and sources and data. But for this talk, the really important ones are going to be MQTT, which is widely used in IoT. We've got a couple of the big industrial IoT protocols, Modbus and OPC UA. We have plugins for those so you can connect directly to those devices. And also consumer smart devices using like Connex and Fibro protocols. And those are all provided already by Telegraf. If we don't have a plugin that you need for your specific device, we also have a couple of external call plugins that will let you write an external script or code and have Telegraf call that to get your metrics. And I mentioned that we're agnostic about where the data goes. We do have an InfluxDB output plugin to write data to our database. But we have got 50 or so different output plugins, including to our competitors like OpenTSDB and Amazon's TimeStream and Datadog. And all of these projects do use Telegraf, and their users use Telegraf to get data into those. Telegraf also has this concept of processor plugins, which sit between the input and the output. Telegraf doesn't store much data on its own, but it can transform it in flight. And two of the most interesting of those are the regex plugin, which lets you write search and replace pattern matching that happens to your data on the fly. And recently we've added the Starlark plugin. And if you don't know Starlark, it's a very small version of Python that's made to be embedded into Go programs. So with this, you can write a Python script that actually just lives inside your Telegraf configuration. It doesn't even have to be external code. So the impetus of this talk, about a year ago, somebody that I knew who works at an Edge framework came to me and he said, hey, we've got a bunch of our customers and users who keep asking, how do we integrate with time series database? Are we planning on doing something with a time series database? And we don't really know, what that would look like. Can you tell us where time series databases should fit into our Edge framework? And it turned out that there wasn't really a simple, good answer that I could give them. So a very simplified view of the IoT space has got 3 different levels. You've got the devices themselves that are connected to sensors, that are getting readings, that are directly controlling machinery. On one end. On the far end, you've got some kind of a server or a cloud or a final destination for all that data where they want that to go to be processed and presented to users. And then in the middle, you've got what's called the IoT Edge, which is usually like a gateway or something that sits in between these two things that ensures that data is being collected and stored properly, puts it out to the cloud when it can. A lot of times that link between the gateway and the cloud is not very reliable. So it's got to store data for short periods of time to be able to put that out there. Also, a lot of times these devices are gathering a huge amount of data that they don't want to push all to the cloud. So that gateway is responsible for just determining what the important bits of that data are that need to be forwarded on. So these are very, very broadly speaking the 3 layers of an IoT Edge stack. And it turns out that InfluxDB can be and is currently being used in all 3 of those layers to various extents. First one I'm going to talk about is the device layer. We don't see InfluxDB too much on this layer just because usually these are, they're very low powered devices. You usually have many, many instances of them. We're talking like thousands, tens of thousands, sometimes hundreds of thousands of instances of these running out depending on how big your your deployment is. Like I said, usually very, very limited Raspberry Pi or smaller devices. Not typically something you want to run a database on, although some of them they can run InfluxDB for small workloads that are coming in. They have mostly been ARM64. We have seen a few ARM32s and even fewer i386 boards that are being used in these, but the vast majority is ARM64. Most of the deployments happen by device images, and those images get built either by taking an InfluxDB binary and putting it in there, or using one of the distro packages we provide for like Debian and Red Hat-based distros. And the predominant use case in this layer is writing data to the database. Like I said, these sensors can collect sometimes, metrics every second, multiple times a second, every microsecond even. So they're generating a huge volume of very small bits of data. So those all have to be written somewhere. So that's the predominant use case on the edge. And it's often used for local data retention. They don't have a lot of space, so you're not going to store like years worth of data on there, but they usually want to see, a few minutes, maybe a few hours worth of data on the device that they can keep track of. So if something goes wrong, they've got a historical account of that. It also lets them monitor how close it's getting to thresholds and be able to report if it's going over a threshold. So if it's getting too hot, having the pressure's built up too much, it's starting to vibrate more than it should, to be able to alert on that. And also to be able to perform anomaly detection. So sometimes a metric's not gotten to one of these thresholds, but it's consistently fluctuating outside of the normal amount. And what that means is hard to say sometimes, but there are machine learning algorithms for detecting that. And so running InfluxDB on these devices allows that to happen. The stacks that we typically see at this level is generally Telegraf and InfluxDB put directly onto the device image. So they're running side by side with each other. Telegraf's configured to connect to like a Modbus or OPC UA data source and putting that data directly into InfluxDB. If they're not using Telegraf, they typically have their own code running on these devices, and so they'll use one of our client libraries to collect that data and put it into InfluxDB itself. And if it's too small to use even one of the client libraries because they're on an ultra-low power device or something, they'll just make HTTP calls directly to our API. The APIs are simple REST API calls with an auth header, so they're real easy to call those directly. I'm going to skip the edge one for now and go straight to the cloud because the edge is really the more interesting, and I want to get these two out of the way first. So in the cloud, we see kind of the opposite end of the spectrum. And when I say cloud, I mean public cloud, private cloud, your own data center, a server in your office. It doesn't really matter whether it's technically cloud or not. The point is that it's some central location where the data is going to. And this is almost always one big, beefy, scalable instance, or at least one instance per specific project that you're working on. Because the whole point is to get data from all these different sources out in the field that you have and get them into one place so you can see all of the data together. These are largely x86-64 servers, although we are starting to see more people ask us for ARM64 support, specifically to be able to run servers on things like the AWS Graviton and other low-power, low-cost ARM servers that are becoming more popular. Usually they're deployed using Docker containers and something like Kubernetes, or if you're old school, you can still use, again, those Debian or Red Hat packages that are still very much in high demand for us. We also now offer a hosted SaaS of InfluxDB Cloud. Like I said, we're trying to outcompete and pre-compete against AWS for this, and so a lot of people just use that and send data to an instance of that. And here, it's kind of the opposite, where read is the more important task going on here. There's still a lot of data being written to the database, but now you're starting to have a bunch of queries to process the data and things like that. So you're doing a lot more querying and reading that data, whereas on the device side, you were doing much more writing. Some of the big use cases that people are doing in the cloud is, again, analyzing the data. Now that you've got everything from all these different sources, all these different readings, and you've got it all in one place, now you can take a holistic view You can start comparing things. You can start running AI algorithms or machine learning algorithms against it to start pulling out some interesting bits of information. And then being able to put those interesting bits of information into your business intelligence solution. We had several people just in the past 2 days asking us about integrating with Power BI, with Tableau, with one of these big enterprise BI systems so that they can take the information and the insights that they're getting from the field and bring that into their decision-making process. And then lastly, being able to visualize and deliver that information to the user, whether that's in one of our dashboards, whether that's in your own user interface, whether that delivery is in the form of a PagerDuty call or an SMS, something to let people know that something's gone terribly wrong in the field. So that's really the last step once you've got all the data and you've done all the manipulation and transformation. I'm going to break this piece down into 2 separate bits because there's usually a part that's bringing data into it and a part that's bringing data out of it, and you can mix and match those 2 however you want. We've seen FogLamp, which is now Fledge. It's an LF Edge project that runs on Edge devices, and they've got a northbound connector that sends data directly up into InfluxDB in a cloud somewhere using that. EdgeX Foundry is another Linux Foundation project. That's one that I work closely with. And they've got a similar setup. Their northbound connectors they call application services. And they've got one for InfluxDB that will connect to InfluxDB Cloud or a remote instance and be able to write data from EdgeX into there. The Eclipse Ditto project. Ditto is an Eclipse IoT sub-project. It's for creating digital twins. And that's when you've got like a virtual replica of a physical device hosted in software on the cloud. And they use InfluxDB to be able to record actual data readings from a physical device and be able to replay them through one of these digital twins. So you can use that to test configuration changes or software changes against an artificial device before you deploy it into the field on a real device. And then still Telegraf is very, very highly used. People install Telegraf on the cloud and then have it either reach down into the edge to pull data out or just have it sit there and listen and have something on the edge that's pushing data up to it. Particle is currently using a setup like this where the Particle devices push data up into Particle's IoT hub, and then IoT hub will push it to a listening instance of Telegraf that's connected to InfluxDB. Once it's in InfluxDB, by far the most popular way of doing something with that data is putting a Grafana dashboard in front of it and being able to visualize data that way. That is still like our #1 use case that I have seen. We're starting to see a lot more people using our Python client and pandas and pandas data frames to connect to either plotting libraries or machine learning libraries or other analysis stuff. That's very heavy Python and pandas already. And then people building their own applications on top of us. A lot of them using Node.js and React, which means that they can use Giraffe, our UI graphing library, because we have built that on top of Node.js and Giraffe, and React. So those are the most popular ways we've seen of people doing something with the data. All right, so now we're going to get to the interesting part, and I got to check my time to see how we're doing. Doing okay. All right. So now the edge, which is, I think what everybody was here for. That's what the topic's about. Again, looking at what the environment is, there's typically only a handful of these devices. You might have like one per building, one per floor of a building, one per factory, one per giant shipping vessel or something like that. You're not talking about thousands of these usually, but dozens at least, maybe hundreds for a big deployment. The hardware is typical about a small PC. More than a Raspberry Pi, they'll have at least a few 3-4 gigs of RAM, generally have significantly more storage space than the devices do, but nowhere near on the scale that you would see for a server or a cloud deployment. One of the big problems that edge devices faced is intermittent connectivity. They'll generally be, feet away from the devices that they're pulling data in from, but they'll be miles and miles away from whatever server they want data to go to, and that connection is a lot more fragile for them. So they need to be able to deal with network downtime without losing data and without the devices becoming completely non-functional. Most of these, they use either distro packages or Docker containers. Docker's a very popular way to get software even onto these edge devices because they are beefy enough to run those. Some of them are running snaps, which is an Ubuntu packaging technology. HP is very big into that, and I think Bosch also is using snap packages for their edge devices. And then there's also Project Eve, which is another Linux Foundation project for containerized edge workloads. And one of our community contributors has built an Eve container to be able to deploy and manage InfluxDB on that platform. And here at this level, the reads and the writes kind of become equally important. You are pulling a lot of data from the connected devices, but you're also reading a lot of that data and transforming that data as well a lot at this level. The biggest use cases are, like I said, collecting data from multiple devices, being able to get it all in the same bucket in the same general format so that you can look at it collectively instead of taking it as a device by device look at it. Being able to send out alerts at the gateway level instead of waiting for that round trip to the cloud and the analysis to happen to the cloud is important. If something's gotten hotter than it should or is vibrating more than it should, you don't want to wait a long time before somebody knows about that and can respond to that. So being able to react to data on the edge is a very big and important use case there. Downsampling is a huge one. Again, the devices are spitting out a whole lot of data, which might be relevant for a minute or 2 minutes, but largely the further away you get from the time the data is collected, the less relevant it gets. So writing tasks to aggregate that data and take like an average of what it was every minute or every hour and be able to reduce the size of the data without necessarily losing a lot of insight and information over the long run is a big thing. Especially if you've got an expensive network connection going out to the cloud, you don't want to send gigabytes of data out there when all you need is like megabytes or kilobytes of information out of it. So these edge devices, they'll use InfluxDB tasks to downsample that data to smaller chunks and then send those off to the cloud. Store and forward is, it goes back to that connectivity issue. If your network connection goes down, you don't want to lose data. So these edge devices need somewhere to store it until the connection comes back up. And InfluxDB is an increasingly popular way to store that data on the edge. Wait for the connection to come back up, and then you can start forwarding it onto your cloud server again. And then local visualizations have really become a lot more important in the edge space. Several companies are pushing data into InfluxDB as they collect it on the edge so that they can give the local people a view of that data. So if you're managing a smart factory, you want to have a dashboard that shows you the state of all your equipment at any point in time without having to rely on a connection out to a cloud site and getting it from there. The stacks that we see, the traditional TIG stack, that's Telegraf, InfluxDB, and Grafana, is still the #1 way of deploying to the edge that we have seen. And that kind of is a testament to the power of those three. Telegraf is the collection agent, InfluxDB for storage, and then Grafana, which we don't make, but is still connects to us really well to provide those dashboards and visualizations. We've also seen one recently. Again, a member of our community created this stack. He calls it Tiguido, and it is a Docker Compose file that will deploy Telegraf, InfluxDB, and Grafana, plus the Mosquito MQTT broker from Eclipse, and those are all configured to work together. So you can deploy this stack that he made, and then you can just start pumping data into the MQTT broker, and it handles everything from there, and that's really cool. A lot of people still, they're writing custom code, and they're using our client libraries to integrate with that. I mentioned EdgeX earlier as something that'll push data up to InfluxDB in the cloud. There is also companies that are using it to push to InfluxDB on the edge itself. So they'll use EdgeX to collect it, and then they'll push it over into InfluxDB with Grafana on that so that you can get that local dashboard to it, as well as pushing it out to the cloud and giving a higher level look at it. AWS Greengrass has started doing something similar. So if you don't know Greengrass, it's an AWS product that lets you run cloud functions like Lambda function workloads on IoT devices. So they've got some AI workloads that they're running on these devices on the edge, doing like computer vision, object recognition, things like that, and then saving the results of that AI analysis into InfluxDB on the edge. And then again, they put Grafana on top of InfluxDB so you can see the rate of processing of that and how it's doing. And Azure does something similar. They've got a very similar setup to Greengrass where you can extend their cloud functionality down onto IoT devices. And they also have a system for storing the results of those processes on the edge in InfluxDB. And they're also using Grafana to present that. So that's it. That's the stacks I know. That's what I've seen out in the wild and by talking to members of our own community. So like I said, I've got links to all of these in the slides. You can get the slides from my website, mhall119.com, or my Twitter, where I'm also mhall119. And you can get all of those and read up more about them. But I wanted to take some time, because we do have, I think, a little bit of time still, to hear from anyone here who's got an IoT stack or a deployment that they have or that they're working on to see what other technology is there that's out there that people are using. And also, if anybody's got any questions, now's the time to ask them. Nope. Anybody here in the IoT space at all? Raise a hand. One, two, couple. OK. What are you using for it? Like, do you have an edge setup, or is it directly devices to cloud that you're working with? No edge yet? No. How about over here? Are you using any kind of edge platform? OK. I saw some hands over there. Are any of you using an edge service at all? OK. OK. So edge is becoming much more relevant. If you don't have an edge stack yet, you are going to want one eventually because of some of the things I mentioned, like connectivity issues, and also a bunch of other things, like security becomes important. Deployments and orchestration and management on the edge becomes a lot more difficult as you grow. So you're eventually going to need something happening on the edge, and these might be some good resources for you to look at. Yes? With what? Binge board? OK. On the board itself?
Yeah, on the visualization.
OK. So it stores it in Mosquito on the device, and then what? Something pulls it from there?
It takes it from Mosquito, and then stores it, parses your MQTT, and then stores it on whatever database you selected,
OK.
and then visualizes it.
OK. What database options does it give you?
I forget now, but I know it's like your typical relational.
OK. All right. Anyone else? Yes? This is a very recent blog post, so like they just wrote this a month ago. So I would imagine it's using the latest Greengrass. I haven't touched Greengrass personally since it first came out, like what, 4 years ago. So I'm not really clear on the state of that and what's changed in that time. Yeah? No, not that I've heard of. We tend to not hear a lot about that unless we're specifically asking. People come in asking for help with Flux or configurations. So no, I haven't heard about Erlang or Elixir. Those are, I don't know, have you seen those being used in like IoT or Edge use cases very much? OK. All right. Yes, Caitlin. Excellent question, Caitlin, who works for InfluxDB and is totally feeding me questions. So her question was, since we're collecting a whole lot of data from a whole lot of devices, how do we downsample that to just what we need? And the way to do that in InfluxDB is with what we call tasks. And tasks are just Flux scripts that get saved in the database, and you can schedule them to run as frequently as you want at certain time spots where you want them to run. We're working now on a way to be able to kick those off with triggers too, so as data comes in, it can trigger these tasks to run. And the way they work is you've got a query and a set of filters in Flux that kind of whittle it down to just the data you want. Then you can pass it to transformation functions to perform aggregations. The most common one is just taking a mean aggregate of the data over a certain period of time. So you give it the window, you want a minute, an hour, a day, whatever, and it'll get you the average for a field over that time in your result. And then once you've got it in the result, you just call the to function, and you tell it where in InfluxDB in a different bucket you want to write that to. And all of our buckets have what's called a retention policy, and that's just how long we let data live in that bucket before we start automatically deleting it for you. So if you're getting high-frequency data from the device, and you only care about your nanosecond precision data for about the last minute, you set a bucket with a 1-minute retention period, and then InfluxDB will automatically start dropping data that's older than that. And then you create a task, and you say, okay, I want to aggregate every 10 seconds, get the average of this, and I want to put it in this other bucket that's got a retention period of hours or days, so it's going to stick around a lot longer, and I can use that to forward out to the cloud. So we make the data smaller, we can store it longer, we can still store more of it on the edge. Thank you, Caitlin. Great question. All right, well, I hope you all have enjoyed the talk. I hope this has been informative for you. Again, get the slides and you can go follow these links. Most of those are coming from partners and users, not from InfluxData itself. But I did have links to a lot of the things I mentioned in the first part of this talk that we do provide. Thank you for coming, and I hope you enjoy the rest of your show.